Architecture of .NET Aspire with David Fowler.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that serves companies using .NET, Azure, and everything else in the Microsoft space, building mission-critical software and rescuing failing projects, all the while empowering software delivery with a proven approach. Quick announcements, we're in the second year of our forums. We have a software architect forum and a software leadership forum. So whether you're on the technical side directly leading a team of developers, or if you're in the management executive chain, a CTO, VP of engineering, more leadership oversight topics, we have an interactive monthly forum for you. You can just sign up at the link on the show notes. And those are really valuable for people who've been engaged with those forums. And I'm the facilitator, and it's a lot of fun. And for those looking for Programming with Palermo, my video podcast, you can just search for it in any of the directories and you'll be able to find it. My guest today on the show is David Fowler. He is a distinguished engineer and has been with Microsoft for over 16 years, working on developer frameworks and tools in the .NET space. He's one of the creators of several popular open source frameworks and tools such as .NET Aspire, NuGet, SignalR, ASP.NET Core. He also architected the Azure SignalR service, which is a service for doing real-time WebSocket-based communication at scale. And he's an avid open source advocate and developer currently focused on simplifying developer experiences in the microservices space. David is also passionate about mentoring and supporting individual contributors in their careers and helping underrepresented folks get interested in technology. David, welcome to the Azure and DevOps podcast. How are you, sir?
I'm doing well. Thanks for having me. That was an awesome intro.
Well, you've done a lot. And I think that there's probably a lot of listeners to the podcast who've seen you in various other spaces, the .NET community stand-ups, the various .NET Conf over the years and other forums. But for the listeners who might not be familiar, I always like to back up a little bit. And you've been at Microsoft for 16 years, but just go way back. Is there some high points in your career that were kind of linchpins that have led you to the kind of work you're doing today?
Yeah, that's a great question. So, I've been around for 16 years now. It's funny. I actually interned twice. So, I've been at Microsoft, for 16 years full time, but I interned twice on the ASP.NET team. So that was a really fun time, and I think that's when I kind of got started being exposed to more of building frameworks and apps. I think I caught the bug really early on when I was trying to build an application, and you get more interested building libraries to make the app building process easier than the app itself.
Yeah.
And the app becomes the slideshow. So that kind of told me I had this thing for wanting to improve developers' lives. And then when I eventually got a job at Microsoft for my internship, I got a chance to kind of work on ASP.NET, right? I had learned ASP.NET while I was in college, and I was like, holy crap, this is amazing. Web forms is great. I worked on web forms. So
Nice.
I love it. And I had a chance to kind of build technology that would touch a ton of developers. So one of the biggest things about working on these teams is impact. You get to work on frameworks, runtimes, projects that kind of enable a ton of people to be able to move faster, build quicker. So that bug I caught really early on. It kind of drove me throughout my career to kind of look for that. What's the next thing that devs are they struggle with, that they have to kind of manage, and how can we make that simpler?
Nice. And the focus of this podcast, .NET Aspire, that definitely falls squarely into that space, making developers' lives easier, making it easier to build .NET applications.
Oh, yeah. Yep. That one was a really fun thing that happened. So we were, I think 5 years ago, 2019, we built this thing called Ty. And Ty was an experiment that happened because a couple of us went offline for I think over a Christmas break. and we said, let's go learn this Kubernetes thing. Let's go play with it and see what comes out.
Yeah.
And it was like, I think 3 of us kind of went off on their own, and we were like, man, there's a lot of stuff here that is like super nice and useful, but it's really hard as a dev who doesn't know enough stuff.
Right.
How do you on ramp to make that like more smooth, right? Do I have to learn about containers, clusters, networking? Like you're kind of exposed to like a lot of concepts all at once when all you want to do is run 2 apps, front end, back end, and have that thing work end to end, right? So we set off, we built a couple of ideas, and one of them was TIE. TIE came out of this experiment. And TIE was, how do I create a Kubernetes-like environment while running locally, integrated into my local dev flow, but I didn't have to like spin up containers and all this stuff. I kind of just said, spin up my front end and back end, and those 2 want to talk. So make sure I can like resolve addresses from that front end to back end easily. So giving you the Kubernetes-like experience without all the stuff, right? I don't have to download a ton of stuff like Kubernetes. They called there were a lot of different distros of Ks back then, like, but it was just heavy to run. So the whole thought was, can we make that overall end-to-end easier? Because maybe I want to just test running two replicas to test things that were hard to test locally. I don't want to have to deploy my entire app to be able to test like one end-to-end scenario with like front end talking to a back end, talking to a queue. So how do you basically make it so I can model these systems like very, very simply locally?
You mentioned something that I just want to touch on before we move on, which is front end and back end. And for people that kind of learned how to program with a JavaScript framework, that's kind of embedded into everything. It's like, okay, you're going to have a front end, and that runs in the browser's memory space. And then you have a back end, which runs on some server infrastructure, and they got to call over the network. But it wasn't always that way. So talk to us about those kinds of architectures, and has the dust finally settled on what is normal for, like this front end, back end, or where things go depending on what you want from them?
It's sadly getting more complex, but I think the paradigms are similar. It's like your front end has to run somewhere, right? And it could either run in your browser as part of your server application. So maybe you own both sides and you have a single application, and all you're doing is writing a piece of JavaScript that is rendered by the server, and that calls the backend, right? That is what I used to do like a long time ago. Very simple. You would add some jQuery. It was very nice. You would deploy one process. It's very simple. Modern JavaScript frameworks, modern client frameworks tend to have you, even during the development time, with a separate full process. So you have Node, and you have a Node backend that serves the React front end or Vue or SvelteKit, those frameworks. And that process is proxying traffic from outbound calls to a backend running .NET, Java, whatever backend you have. And it means the simplest hello world where I have a JavaScript front end and a backend that's a .NET backend requires running 2 things. And having the thing in the front end know the address at the backend, so the IP address that's like hard coded. So you're being exposed now to like networking and proxies and cores issues before you even get your hello world going, right? And I think over time things have just gotten more complex. So the question is, do you try to convince everyone that putting things into the same process is the best way forward? Or do you try to kind of meet them where they're at and say, okay, if you choose this path, can we make it such that I can develop a front end separately and a back end, and I can in one gesture spin up both, configure it for you, and have it just work without having to understand all the pieces like to do basic stuff, right?
Yeah. Well, if you have a WPF system tray application, or you have a mobile application or WPF, well, there's a front end process that's running on a client computer somewhere that's separate from your back end process running in Azure. But I have to also call out, we call it back end process, but years ago, didn't we call back end the data tier? And now we're calling back end like a web service tier or a queue handler.
End tier, man.
Right.
Yeah. It's I think backend things were definitely simpler, right? And I think it's possible that through experience, through learning that if you build systems that are very coupled, that over time, if you need to scale, that you do end up having to do a rewrite. So I
Yeah.
think what you end up seeing though is people start with the best practices really early on, and you get this mix of maybe me having a front end, a back end, a database tier, a caching tier isn't required for my scale, but if I scale up, then I'm fine.
Yeah.
I think people are still in the situation of we tried the thing where we don't have any layering that won't scale. I want to make sure one day I can support Amazon style traffic. So let me start with a distributed system, well layered, well designed from the get go. There's pros and cons with that. Like if you choose to, so as an example, people always ask me, what auth should I choose? And I'll say, okay, what do you like? I have to ask 10 more questions and go through a workflow so I understand how you're deploying, why you're deploying that way. Do I try to change your mind and say, well, if you choose to deploy a separate front end from your back end, like then you're gonna have to choose this kind of auth, right?
Right.
Versus that kind of auth that's simpler. Like maybe just cookies is good enough, but maybe you heard online that cookies are bad, and so you want jot tokens, and now you've designed your entire system under the premise that that one thing is better, without grokking the entire end-to-end or trade-offs required to make the whole thing work well, right? So I think you end up seeing people going in circles trying to figure out what the best choice is for what they chose to design their system with. So they kind of pick an architecture before understanding the implications of it.
Yeah.
That's normal, I guess. That's part of software engineering.
Right.
Yeah.
Well, most listeners are listening to this right on the heels of .NET Conf 2024.
Whoop, whoop.
And .NET Aspire has been out for a while. Some people have been playing around with it and doing some things. And so could you catch us up on what are some of the scenarios that maybe they weren't quite smooth? And there's been a lot of traction where if somebody looked at it and then kind of pulled away thinking, oh man, I really need this and it's not quite there, what reason should they come back and take another look now?
It's a good question. So we shipped Aspire V8 a build this year in May, and it had all the right things. The foundation was kind of being set, but it was just missing a lot of like niceties to make the end-to-ends work really well. So we got a lot of feedback about, I want to say 5 or 6 specific areas, and we kind of try to laser focus on the developer experience. So anything that was an adoption blocker from people trying out the first version, we set our eyes on to be like, okay, we're going to make sure that works for the next version. One of the really easy ones is persistent containers. When you create an Aspire application, and let's say you have an application with a SQL Server and a cache and a RabbitMQ backend, and I run the application, I run it in VS or VS Code, and it spins up the application. I dev for a little bit, I change my application, I stop debugging, it tears the containers down and the apps down.
It's including the storage in the container.
Including the storage. And we have support for volume, so you can make sure that the data isn't lost between runs. But if you launch RabbitMQ, it takes about 20 seconds on my super fast machine to boot up that container.
Yeah.
And 20 seconds every F5 is a really, really big hit to your dev loop.
Right.
So we ended up spending a lot of time this release working on making containers persistent. Well, not by default, but you can opt into it. So you can say, add RabbitMQ with lifetime persistent, and it will persist across multiple runs now. And that was it wasn't a simple feature, but it was one that was like high impact for people, right? Other big one, the most requested feature was being able to start and stop a resource, which is a project, a container, any kind of thing that runs in the dashboard.
Yeah.
The Aspire dashboard got a lot of updates this release. It's a lot better UX that happened, but people wanted it to be more incremental. So imagine you have eShop has 22 services. So you launch eShop, it spins up 22 services, including containers, databases, and projects. And you want to be able to make changes and reload that one project.
Yeah.
So people were really annoyed at having to tear down the entire thing and reboot and then wait the entire time. So even though the containers are now persistent, could you make it so I don't have to tear down my entire app to make a change? So in Aspire 9, you can go to your IDE, make a change, do a build, and it will kill that one process, and you can restart it. Or you can say stop process, make a change, rebuild, and then start process. So it keeps you in flow more. You don't have to kill the entire session to make one change to an app. And you're going to see more things along that line, I think, going forward. We want to keep more of the state persistent. So
Yeah.
we can, only tear down the things that change as we go forward.
You mentioned RabbitMQ and made me think of all the trouble some developers have had using Azure Service Bus. And of course, you can't run Azure Service Bus locally. So you got to find something to mimic a queue. And
Yep.
so has that been one of the scenarios, using RabbitMQ to be a dev comparable experience when they know that production is going to be Azure Service Bus?
Yeah, a lot of people, we learned a lot of things during the Aspire dev cycle, like watching people use it and seeing how they use it. One of the very common scenarios was people were using RabbitMQ. It's probably the most common one people use as a implementation detail for their message bus to test things locally. And they would deploy using Service Bus or something else, Kafka maybe. And we actually spent a lot of time talking to the Service Bus team about, hey, are you guys gonna have an emulator like eventually soon?
Right.
And there's a long issue opened by Jimmy Bogard that's like has 1,000 upvotes. And, like, we really want an emulator.
You have to.
I think exactly for testing it, it becomes really a really nice. I won't say required. It really becomes required to make your test stable.
Yep.
So I think that was one of the big things that we kind of pushed. We asked questions, and it turns out that team was actually working on the emulator. So we're gonna get an emulator hopefully pretty soon. I saw a sneak peek of it running.
Okay.
So I was like, oh my gosh, it's coming eventually. But Aspire itself, I believe, is helping people make these end-to-ends much easier. So you can grab an emulator from somewhere if there's one, grab Azure for storage, run it locally, configure the connection string, grab information from it. Aspire is trying to automate all the things you have to do by hand to make these services that have multiple parts work well together. Yeah, and it brings me to actually the other piece that was, I think, a big part of what we want to get done in Aspire 9 was deployment. Deployment in Aspire is the least mature part of the entire thing. We have big aspirations, but I think we didn't get a chance to kind of go all the way.
Yeah.
So people had to kind of like break glass a lot in V8. So say you want to deploy Azure SQL with your service. If you want to change the SKU because the default is too expensive, maybe you want to like tweak the bicep somehow.
Yeah.
You could do it. The APIs were not great. They weren't finished. They weren't in a state of like, this works well. And they were marked as preview.
Yeah.
The Azure SDK team, with us, we worked together with that team. For 9, we code gen the entire Azure API service based on what the spec in the REST API says, and we give you a nice C# API over that. So now when you say give me a Azure SQL, you can in C# just override a method and say I want to use this SKU, and you get objects. You don't have to worry about like super low level strings and bicep. You can just set objects, and that change in itself was about enabling others to kind of build insane things, right? So I want to be able to, for every Azure resource, ensure that I use TLS 1.2, right? You can start applying cross-cutting policies at the dev level. So imagine someone can just build libraries that kind of encapsulate policy and apply it to all of your resources at the dev level. And devs pull a package from their infra team and say, I'm gonna make sure the company standards are all here. Let me just call a method. That's what we want to enable.
Okay, you said, I just want to make sure I heard this right. You code-genned the entire Azure API. Did I hear that right?
Yeah, so we chose we chose a set of resources to start with.
Okay.
But it's pretty much the entire API surface. And the Azure SDK team does this today if you use their APIs to kind of provision resources. So it's the same pattern, but we kind of have a separate API to kind of emit bicep, and it's code-gen. So like we just say, hey team, can you guys add support for Key Vault?
Yeah.
And they'll literally spit out a package that has like all the API surface. And we just like
so regardless of Aspire, regardless of .NET Aspire, this right there, this is huge and monumental.
Super useful.
We're not talking about ARM templates. We're not talking about bicep. We're not talking about the command line AZ or AZD. We're talking about object-oriented .NET programmable.
Yeah. Yep.
Azure resource implementation, changing.
Yeah. And we didn't want to build it. So the Aspire team is kind of this team that spreads across a lot of different teams in the org.
Yeah.
So we have people on the ACD team working on Aspire, on the Azure SDK team helping us with it. But the way we kind of think about building Aspire is everything goes in the right place. So even though you have a feature that's kind of an Aspire experience, we make sure that the APIs that are owned by the Azure team are built by that team, and they're building it in a way that isn't tied to Aspire.
Yeah.
So we build things in the right layers in the stack, and then it comes together in Aspire.
Nice.
So Aspire ends up driving lots of features across .NET, across the stack, across tooling, because we need X, and to make X work, we need these 4 features: one in tooling, one in Azure, one in AZD, one in blah.
Yeah.
And we have to do that because it keeps the design clean.
Yeah.
Right. You can imagine a world that said, like, we should just put this in the dashboard or put this Azure thing in the blah. And then we have to figure out, if you're not Azure, if you're going to AWS or you're going to GCP, we don't want certain features in certain places, or we don't want to imply that, you're going to Azure because you're using Aspire.
Yes.
If you choose to use the Azure package, then you're all in. You made a choice. You opted into Azure.
Yep.
You're using the Azure call. Like, it's in your code. It's not tied to Azure.
Right.
So we layer things in a way that's like the core is clean, and there's an extensibility model, and you plug into it, and then the Azure, what we call the Azure hosting integrations, are built on top of this like super clean layers of abstraction.
You mentioned various teams have a infrastructure library that could just be brought into all the different apps and affecting it, because now it's .NET. So now it opens up NuGet to all kinds of infrastructure related standards. It reminds me of the genesis of DevOps, when even before the DevOps name was coined, when it was for a brief time called Agile System Administration, before Patrick Dubois was told, it's a stupid name, call it DevOps. But the spirit of it is like, we have all this automation and engineering practices goodness in software development. How do we apply it to system administration? This has been a missing piece, the ability to just, in the regular code of the application anyway, be able to influence and change whatever we need to about the infrastructure, instead of having a totally different stack.
That was, I think, one of the key innovations was the app host. The app host was, we all sat in a room one day and we said there are kind of 2 kinds of problems to solve in this space. And one was like, I think it was called practical problems, and there's another name for the other one. And one was like, how do you solve distributed system state, things that databases solve, and like idempotency, app model concerns. Like, I'm building an app in that system. I need to store, I need to have distributed locks, et cetera, et cetera.
Yeah.
Then there was like the other part. How do I configure these 2 apps so that they have the right information? And we actually spoke to a lot of customers and asked around, like, how does your organization manage secrets? Like, just that super simple question.
Yeah.
And the amount of diversity in the responses was kind of jarring. Like, some people have a OneNote, like shared OneNote with secrets. And, when a dev has a new requirement, you ask the team, you file an issue, team gives you a new thing to talk to.
Yeah.
And it wasn't consistent. So we kind of sat down and said, okay, if the devs can model their dependencies in their terms, their point of view, right? So I have Redis, I need to use it. I can do it with reference. Very simple kind of app model design. How does that translate into what gets deployed? And I think there's kind of like two main patterns. One is, I'm a small team. My DevOps person is me. I'm kind of like part of a very small team, and the DevOps role is a role of one of the engineers. And what happens immediately is you have to kind of learn a whole new stack. You have to go learn Bicep. It's funny. The whole team had me and myself. I thought I knew Azure.
Yeah.
I didn't know anything. Just having to learn Bicep and ARM and Azure and deployments and pipelines and how to make it all work securely together and work well. And I thought to myself, this feels like a thing where the lower layers of abstraction like are ripe for being targeted. So you build a higher level expression and you target the lower level pieces, right?
Yeah.
It's like compile to ARM, compile to Bicep, right? And this like take the concepts I need to talk to Redis
hmm
as like developer intent, and then based on your team's infra or whatever requirements you have, spit out the most secure infra, or spit out the safest infra, or spit out infra that matches what my company needs. That's the intent of what we're building. It's gonna take a little bit to finally get there in the end, but
Yeah.
we're making really good progress. So like in Aspire 9, we now have like the ability to basically modify your container apps, modify the Azure resources in full. You can modify without having to drop the bicep. And I think moving on, we will be able to modify every resource that we create, right? It's more of a time constraint thing and a design thing than it is like Aspire can't do this yet. It's more
Right.
we are heading towards this model, and we're so close, but we're not there yet.
Is it part of the overall vision to, at some point, be able to just create an empty Visual Studio solution and then just go to NuGet.org and say, hey, give me a skeleton for this type of application?
Yeah, so that's a really, really good question. Right now, we haven't built this yet, but we've discussed a lot of times around like, do we want to have better scaffolding?
hmm
I struggle with templates personally because I think you end up with the combinatorics problem.
Yeah.
But part of me is hoping like AI can help, or prompting in some way. You can say like, give me this, give me that, give me this, and it knows enough Aspire guts to kind of spill a template based on what you ask for.
Yeah.
Right? Give me two backends, two front ends, blah 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 blah.
Well,
There's also the idea of like maybe you can do a visual designer where you can kind of like draw lines and boxes and spit out a default Aspire template. Like there's a lot
well,
of potential when you begin to model this stuff.
I remember going back to 2001, 2002, and every rev of technology since, there's always been in organizations with multiple dev teams the need for a template, and the organizations have a template, and they end up just having a Git repository that says, oh, here's a shell of the application, and so we're going to make it generally like this. And so, yeah, maybe for the entire industry, you have this combinatorial problem. Maybe Microsoft could say, look, everybody needs, I don't know, Blazor WebAssembly, web services, and then Azure
Default.
SQL, and say that's our base
Yeah.
template, and everything bolts onto that. But for
Yeah.
organizations, I think every
Yeah.
organization needs the ability to say, okay, this is our base structure that we're striving for. If we as an organization could put it in our NuGet.
Yeah. That's a big one. So I'll tell you about a thing we started doing recently. It's Aspire for 1P. And the idea is that within Microsoft, we have the same problems.
Mm-hmm. Yeah.
And the mission is the same. It is, can we create templates and integrations for teams at Microsoft building services
Mm-hmm.
that kind of help them get from zero to kind of going really fast, right? Like we're gonna automate all the manual craft you have to do normally, and we're gonna build tools to spit out, deployment infra and all that stuff. And we're in that same playbook internally right now. So the same idea is there. Like,
Yeah.
can we have a template for new teams? We have systems that we run internally that don't run in the third P in the 3P world. Same thing there. Like, file new, please configure my my telemetry to go to this place, configure gRPC in a very specific way. And I think it works really well when it's localized to the team, to the
Mm-hmm.
org, to the
Yeah.
whatever. That's where you get the biggest benefit, I think. So we're definitely going to look into more of doing that.
Okay.
Sure.
You mentioned just the Azure API again. Does this include networking and the firewall rules?
Not yet. It will.
Not yet. Okay.
It
Okay.
includes firewall rules for Azure resources. We didn't do VNet yet. That's happening like as soon as we ship this
Yeah.
the first version. We're gonna add support. Like, I mean, one of the things I know we're like spending time on deployment, and like Aspire has a lot of value for development, but I spent a lot of time on this.
Yeah.
So I'll talk about this just a little bit more. One of the things we theorize, right, is possible, is we could spit out a secure networking environment by default. So right now, when Aspire kind of creates an environment for an ACA for you to deploy to,
Mhm.
there is no VNet, there's no virtual network. It's just kind of the Azure container apps environment, your container apps that are internal or external, and the PaaS service, so your database, your cache, or whatever. And we try our best to lock down using firewall rules access to those PaaS services.
Yeah.
But in really, really stringent like enterprises, or even in Microsoft, you need to do a more secure deployment. So like
Yeah.
VNets, private links, all that stuff, zone DNS. By the way, I barely know this stuff very well. I know it like just enough to be dangerous.
There's
so
a lot.
you're gonna hear
There's
me
a
say
lot to
stuff.
know in that space. There really is.
But we theorize if we're treating this thing like a completion target, if you tell us you reference Redis, like we could ask you what your environment has, and we can kind of spit out the most secure by default environment with a VNet, private link, and all this stuff. So
Yeah.
I am looking forward to spending energy in that space where we kind of have a default path that says, okay, given this topology, spit out this infra, and then we give you a chance to add your own infra. So you can kind of like tack on more stuff, delete things, add more things, and you're given our model. You can say like, here's what we saw in the app model. You said Redis and front end, right? Go and turn that into a crazy like deployment with more things. That's kind of where I think we're gonna end up going, and I'm looking forward to seeing people learn the framework and build interesting things that we haven't even thought about, right? Like someone asked me about SQL Elastic pools, and I said we don't have support for your scenario, but like here's a code snippet you can use to just turn it on.
Yeah,
like 10 lines of code to like loop over all the resources and add a pool to it, like, and it's just that power, that ease, I think is the thing that I think we want people to realize is there with Aspire. You can really enhance both, local development, testing, and producing deployment assets, that workflow.
Gotcha. So a lot of good deployment stuff is coming, but back to the DevStory. What are the things you're most excited about?
I think this thing called waiting for dependencies. So really early on, we got this feedback. Hey, I need to be able to wait for my SQL Server to be up before I run a migration.
Okay. Yep.
And we always said, you can't do that in deployment. We are not going to do it in local dev because it will teach you to make sure your app is resilient so that you don't make assumptions about things being up. We did that for about half a year. And even though the database clients and other client APIs in Aspire are resilient, it just, for local development scenarios, it's just so much easier.
Yeah.
To wait. So we caved and we said, okay, we're gonna just do wait for. And wait for was a really complex feature. At first, it seems easy, right? Like, don't start this before that thing, So you figure out dependencies and you just start things in order. But when do you start the project? Like, when do you start your app? How do you know when the app is healthy? How do you know when RabbitMQ, which is running, but is spinning up for 20 seconds? How do you know that it's not ready? So we had to integrate health checks. So we built this system now that's like checking health of all the resources when you run in dev locally, and the dashboard shows you, running but unhealthy, and the app has to coordinate things based on health and state. So but I think it's a really easy to use feature where you can just say, add project, wait for SQL, or add project, wait for completion, migrations. So you can kind of do complex local workflows. And it's super nice.
So does that mean that the wait for the top level application does a chain call down to all its dependencies? So we could check the health check of the top level, and it's now automatically going to give
down.
you an error, or if one thing is not good.
Yes. That's
awesome,
right.
because that's a good chunk of work that developers have always had to do.
Yeah.
Now it's automatic.
It's in there by default. Funny, the way it works is built on other public APIs. So if you want to run, let's say you want to seed images into your blob storage, into your local emulator, on start, you would have to kind of poll, figure out when it started, figure out when it was healthy.
Yeah.
You can now, in the app host, because it's C# you're writing, you can say, I want to subscribe to the ready event for that Azure storage emulator, and call me when that happens, and I'll just run code. So you can just write more C# to coordinate all these local environment scenarios. We have a lot of teams in Microsoft and companies outside that are using Aspire to make bootstrapping their projects easier. So new dev joins team, they have to go read the README.
Yeah.
It's 1,000 lines. They got to configure 20 things, set up certs here, change stuff here, config files here.
Yep.
They're using Aspire to literally automate all those steps. So you don't write documentation, you just write code. And
Nice.
then F5 turns into bootstrap all the environments, make it all work, give a dashboard, show errors or show nice things, and it all just kind of spins up and works.
Very cool. I know we're not going back to ops, but this dev scenario, you literally hook it up to one of the operations, ping tools, the Are You Up? And now you have complete health check telemetry just about automatically, it sounds like.
Yeah.
Very cool.
It's super nice. And everything we built is extensible. I think one of the things with Aspire that we want to enable really early on was the effect we did with ASP.NET Core. I don't have a middleware for blah built in.
Okay.
I'll do it myself. So like that should be your instinct. I don't see support for, I don't know, random open source library that I want to use but isn't there. I can go build it myself. I can go plug into the model and make it work.
Yeah.
That was one of the main things we want to enable with code over kind of configuration. I was like, we could model running a Redis container locally and then running an Azure Redis in Azure.
Yep.
If we can do it, we want to make sure you can do it.
Yep.
So you can copy our patterns, copy what we're doing.
Right.
And there's no real, if it's not there in the box in Aspire, I can't do it feeling. I added my own stuff.
Well, the first scenario is going to be all of the legacy and existing systems that every company has. Or
yes,
hey, I need to be able to talk to this, Olay component that's running on this particular server. I mean, just compatibility with everything that you may have.
Yep, exactly. And that brings me to integrations. Integrations got renamed from components. Integrations are basically, you can write an integration that integrates with some third-party system or first-party system, and we give you a pattern for doing it. So you can write a thing that runs in the host, and that thing is job is to spin up a resource, somewhere in Azure or in some cloud or in a container or point to something else. And its job is to provide configuration for the app. And then client integrations basically wrap client libraries and just turn on a whole bunch of things like telemetry and resiliency and all kinds of configuration enabled things to make it easy to use those libraries. But they're very thin. And once you understand the pattern, our hope is that people begin to Asperify a ton of their libraries. All right. So we're hoping we started a pattern and a movement around hey, here's how you build the integration for SQL Server. Go build yours for your own database. Go build your own thing. Put it on NuGet. Build your own end-to-end stuff, and then have it plug into the current system.
In your vision for this, do you see existing third-party service providers that provide a NuGet package to call their service? Do you see those things being wrapped in this way, or is that not?
Yes.
Okay.
Yes. I mean, the ultimate goal is you don't need the Aspire integration because whatever Aspire wanted, they do natively.
Mm-hmm.
But I think in the long run, what we want is to enable all these third-party databases, services, caches, buses to all support kind of the Aspire model. We ended up bootstrapping a lot of the integrations ourselves in the first version, but the goal isn't for us to own every integration.
Right.
It's definitely to encourage more people to kind of build the all-in-one, what we call glue packages. One of the important things that we didn't do is we had a discussion really early on about, do we build abstractions or do we just wrap and glue things together? And we had a back and forth, should we build an iCache? Do we have a Redis cache? Do we have all those implementations? Are we going to do a bad job because it's going to be really not, it won't meet the needs of people who need Redis? And we said our mantra is more glue, less abstractions for that specifically, because we have to keep up with the underlying client library. When they're version, we have the version. We're taking on the burden of basically being the arbiter of all these other concerns, right? Today, if you want to use Redis with Azure, if you want to use Azure Redis with managed identity, you have to wire up a couple libraries and you have to write a bunch of code that isn't really memorable to make the whole thing work well.
Yeah.
So what if that instead was a single line of code you just call add blah, and we took on the burden of doing it for you? That's kind of what we're doing. So it's not as though we're inventing a whole bunch of new client features or libraries to talk to Redis, or we are taking library A, library B, C, D, E, and F, and we're saying, okay, here's a package that uses these 4 libraries.
Yeah.
You would have done it yourself if you really wanted a reliable, observable, consistent view of this library. We're going to do it for you and call it a Spire block. Just, here you go.
So does that mean that instead of interfaces, you're defining extension methods?
Yeah.
Okay.
Got it. Yep. And all those do is they glue the current client library together. They put it in DI. They manage lifetime for you. They turn on telemetry, resiliency. You kind of have to know the right version of the package from OpenTelemetry and the main package and the name of the telemetry source to turn on. We're kind of doing that for you. So when you add Redis, you pull up the dashboard, you see telemetry for your HTTP calls and your calls into Redis. And you didn't have to do anything to turn it on.
Right. So you mentioned eShop, and we'll include a link in the show notes for the listeners who haven't really given that a look. But through that project, invariably with all the investigation, you've seen how, well, the old startup CS and then program CS can get long and long and long and long. Like there's a lot going on. And now the Aspire, the app host kind of takes some of the concerns. But what advice or what have you learned about how to best organize this, for better term, startup procedural logic?
Yeah, thus far, so initially when we changed the model to be more linear and more procedural, as you said it, first instincts, extension methods for everything, right? Okay. Just like more of them that kind of merge multiple, shared concepts. So, add auth services instead of like 15 calls, you have one call that kind of moves. And I think it's the same thing that we do today with object. With OOP, you encapsulate a bunch of behavior into an object. This is more functional, more procedural. So you're still trying to encapsulate behavior, but you're doing it in like a really simple way. So I think what we've seen in trying to clean up the eShop code was we basically made a lot of the shared components. We moved to library. So that's one of the big things. So anything that's actually shared, auth configuration, auth setup, open API setup, that we could move to configuration. We kind of opted for config over code for those things.
Mm-hmm.
So you'll see in eShop, there's a pattern where you can you can put the Open API a couple of properties in config, and then the service defaults in eShop will read that configuration if it's there and set up some basic defaults. I think that pattern works really well if the thing being described is easy to describe in configuration. If it requires lambdas and callbacks and code, then maybe it's not a good pattern for that. But I think for the most part, moving things to configuration that can be in configuration, moving things into extension methods that are shared is a good pattern as well. I would definitely look at eShop. We spent a lot of time on a lot of the program CS to make it look as clean as possible.
Mm-hmm.
I think we did a good job. Actually, looked at it last night and was like, man, we did a pretty good job with like the program CS for a lot of these different things. All of it isn't fully cleaned up, but I think for the most part, the APIs, gRPC stuff is all pretty well factored, and it shows you how you can build minimal APIs in a clean way.
Mm-hmm.
There's always complaints about minimal APIs not being structured and needing to scan things, and I'm like, well, if you don't have 1,000 APIs in one project, it's fine to have an extension method, in a class that kind of defines all the routes.
Yeah.
I think it looks pretty nice. So I'm a big fan of that style where you say map, person API, and person API has, an extension and a class with methods with all the APIs. And yet it looks like a controller because .NET has objects and classes,
right?
And C# is object oriented, but it is still imperative. You're still running code to add things to a builder. You aren't like declaring the controller to have it be discovered, right? Mm-hmm. So it still has that pattern inversion that we have for APIs.
Nice. As we get to the end of our show here, you had mentioned one application or one process resolving and knowing how to contact another one, how to call it. What's the architectural relationship between that capability in the dev experience locally and Azure Container Apps with Dapper, DAPR?
Good question. Really good question. So those who don't know, Dapper is, I always tell people Dapper is a platform, a cloud abstraction, if you may. So in Dapper is intentionally trying to be an abstraction. So you want to use state, you call into the state store APIs. You don't talk to stores. You don't talk to kind of key byte to Redis. you talk to Dapper APIs. So Dapper is intentionally trying to be an abstraction over different backend services. And it happens to be a sidecar so it can work out of process and it can work with any language. That's kind of the innovation for Dapper, right? Dapper also has service discovery. So Dapper has that sidecar running for every process in your application. And you can kind of talk through it in a secure way to discover other services, right? So you can kind of call through Dapper APIs to say, I want to invoke the Dapper service described on that side of my application. And Dapper makes sure there's MTLS between the different services, and it's done in a very secure way. What Aspire does is much dumber. So Aspire treats service discovery as a naming problem. And in local development, what we're trying to do is replace your hard-coded IP address with a developer-centric name.
Mm-hmm.
So you called your backend, backend. You call your front end, front end. If you want to talk from the front end to the backend, you do HTTP : backend. And to make that work locally, there's like a lot of options, right? It could be maybe we hook your OS's resolver for DNS. We change our whole file and we point back into 127.0.0.1. That requires like admin privileges. It's very complex, very messy. So instead, what we do is something very simple that works only for .NET processes. So if you have a .NET process, Aspire will inject a schema of a service of configuration that says like services __ scheme __ 0, and it will say that's your address. And the mental model is we're going to do what developers would have to do if they want to make this code work well locally and when deployed. So developer A isn't going to hard code localhost 746, hopefully they won't, 7461 in their code. They're going to put it in config.
Yeah.
So same thing here. You in your code reference the name of the service, and then config gives you indirection to say that name means this IP address. When you're in container apps, we actually use the same pattern where when your app is spun up, if you reference other projects or other endpoints in your Aspire app host, we will compile to bicep that says reference this environment variable name, but use this key instead.
Mm-hmm.
And that key resolves the actual underlying name of the target service in Azure Container Apps.
Okay, so DAPR, Dapper, isn't required for .NET Aspire applications, just to function in a basic way. It's just if we need to resolve a different container that is not built and deployed from that .NET Aspire Visual Studio solution.
Yep.
Got it. Yeah, that's pretty straightforward.
Yeah, there's definitely overlap, but they don't collide.
Yeah.
If that makes sense. So you can if you're using the service discovery APIs that we provide in .NET, I guess since 8 now, then you can just use the pattern to say like, put in configuration, services, name of service, IP address. That'll work fine.
Nice.
If you happen to use Dapper, you can just use the Dapper client just fine and it will work. But there's no overlap those two things at all.
Okay. Well, as we close up here, we'll include links to everything we talked about in the show notes and the eShop
Awesome.
project and all the .NET Aspire sessions at .NET Conf. Is there any closing word you'd like to share with the listeners?
Yeah, sure. I have they gave me a talk. They let me talk at the conference for like half an hour. I have a vision talk where I'm hoping to go over some of this in more detail. When we were first building Aspire, I think we knew we wanted to rebuild what we have at TIE for local dev. But I think as we progressed, it became clear that this was about targeting every phase of the SDLC. So like local dev is first, testing is second,
Mm-hmm.
and then deployment is third. So we want to kind of capture the entire thing. And we're at different parts in our journey for each one. And I want to kind of express to people, okay, we are here right now,
Mm-hmm.
but next year we're going to be here.
Yeah.
And we will have seen kind of the vision of, being able to model your application in C#, .NET code, and then having that's the central point of the whole thing. All the outcomes are from that one point. The reason we can create bicep and the reason we can do testing, the reason we can launch your application is because we have this model. That model kind of drives the entire end-to-end.
Mm-hmm.
Be what it is.
Nice. Well, David Fowler, thank you so much for coming on the Azure and DevOps podcast and sharing with us all things .NET Aspire. I really appreciate it.
Awesome.
And until next time, dear listener, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.